help them fight back and combat the threat of ransomware.
And later on, we're also going to be hearing from Harley Puckett on what IBM is doing with the Spectrum Protect platform to build on the strategic direction as outlined by Steve.
And on the subject of building on that direction, Al and I are now going to share with you the future plans and all the exciting things that are happening at the world of Predator. So Al, will I go and get my laptop and get set up for the demo? I'll hand over to you.
Thanks, Rick. Okay, so now we're going to take a much closer look at Predator. And when we talk about Predator, we're talking about the Predator automation and orchestration platform, a software product delivered as a SaaS product, so it's subscription based, hosted in the IBM cloud. Why are we going to look at Predator? Well, Predator is part of your armory to help you take the fight back to the threat of ransomware and cyber attack. Now, when we looked at the design criteria for the Predator platform, we tried to distill the problem down to a single, simple question. That question is, can I, or to phrase it another way, how can I recover or restore a clean backup? That is basically the fundamental problem that we're trying to solve with Predator orchestration and automation technology. If we can do that, we can't solve all of the security issues that you are going to face as a large enterprise business. But at least we can attempt to ensure that the investment that you've made in your backup recovery technology over the last few years, could be hundreds of thousands of euros, dollars, pounds, for some of you, millions of euros, dollars, and pounds. Ultimately, if you cannot answer confidently that question, what was the point of that investment? And that's what we're here to help you try and answer as confidently as possible. So let's look at where we fit in. All of you today, I hope, or most of you, will have invested at some point in the near or distant past in the IBM backup recovery technology. Most of you will have Spectrum Protect. Some of you will have invested in IBM's latest Spectrum Protect technology, which is called Spectrum Protect Plus. Underneath that, you'll have a range of storage assets, tape libraries, storage subsystems. Perhaps you're utilizing some cloud, some object storage, etc. This is constantly changing, and the good news is whatever IBM supports, we support. Some of you will have a traditional workload infrastructure that you're having to protect, Unix, bare metal systems. Many of you, though, will be wanting to use the IBM backup recovery technology to protect your distributed systems, which could be virtual, VMware, Hyper-V. Some of you may even be starting to experiment with backing up cloud-native workloads, containers, using distributions such as Kubernetes, or perhaps opinionated distributions of Kubernetes, such as Red Hat OpenShift. You may even want to protect SaaS applications hosted in public cloud. So what we can see from here is all of this environment is under your control. Hopefully all of it has been protected by one of the two products, Spectrum Protect or Spectrum Protect Plus. Where Predator sits is atop of this as an automation and orchestration platform designed specifically for the IBM Spectrum Protect stack. The primary function of Predator is to gather and collect enormous amounts of metadata to help us analyze that data so that we can make better decisions or perform better actions. So for many of you, you may already be using Predator as a decision support mechanism, a decision support tool to help you improve the day-to-day management of your Spectrum Protect estate. Your motivation for doing that may be to improve outcomes make your backup success rate more performant, make your backups go faster and be more efficient, or it may be that you need to report for compliance or just for line management purposes. What we're going to go into in much more detail now, though, is the automation and orchestration side of Predator. This is the part of Predator which is maniacally focused on answering that question that we talked about earlier. How can I recover a clean backup of my data? And more importantly, how can we do it in the event of a ransomware attack? So let's look at the bigger picture of security. For all of you cybersecurity professionals out there, you will have heard of the NIST framework. Now let's remove those elements of NIST that Predator's not designed to solve. And ultimately we're going to be left with two: respond and recover. So, identify, protect and detect. There are a myriad of cybersecurity tools that will help you provide defense against attack. With backup, where we come in is in that final two phases is, okay, so you've had an attack, how do we best respond and how do we recover? Now bear in mind, if you're in that situation, it's not business as usual. You are having to respond in a crisis. It's a problem. It's not just a problem, it's a chaotic problem. Your hair is on fire. How do you do that? Well, rest assured, it's probably best that you don't do it manually and make it up for the first time. You need to rehearse, you need to practice, you need to train. This is why automation and orchestration is so critically important to preparing your business and making it as data resilient as possible. But before we go into the detail of Predator, let's just step back and look at the bigger picture. First of all, backup isn't the only way you can protect your environment and architect your environment to mitigate against loss of data. With primary storage, we've got snapshots. We've even got immutable snapshots now. You can do clustering, you can do geo-dispersion, all to protect your systems and your enterprise from losing data. Why do we have that? Well, we know that data loss can happen for many, many reasons. It may be user error. It may be a hardware failure. We know hardware is becoming more reliable, but it still fails. It may be a natural disaster. The old traditional design points for disaster recovery: flooding of the data center, earthquake, flood, fire, whatever. It's only recently that we've started to think about the threat of cybercrime as being a possible reason, nay, even a probable reason for you losing data or having data compromised at some point in the future. Now, the reason why we have backup, let's talk about that for a minute. Well, we know that those previous technologies like snapshots, clustering, geo-dispersion can all fail at some point. Not all necessarily at the same time, which is why we need backup. For many of you, your backup is often seen as insurance policy. It's your last line of defense. However, backup, when you have to rely on it, have you tested it? Can you feel totally comfortable that it will deliver? As I've said, you've made the investment. When you push that button, can you guarantee that restore? And the reason why it's not always so predictable and you can't guarantee it is because backup is complicated. Why is it complicated? Well, we make it more complicated by often having more than one backup product. We have multiple different versions, multiple backup products. We have data dispersed over different data centers. Sometimes that could be in the public cloud now, it could be at the edge. We have multiple different types of workloads. It's not homogeneous. Bare metal, physical machines, Unix-based systems, Windows-based systems, virtualized systems, increasingly container-based systems. And finally, from our backups, we don't just have one single copy, we have multiple copies to choose from. So again, when your hair is on fire and you're in that situation when you need to restore, which backup copy do you choose to guarantee your restoration point? Now let's look at the statistics. Fortunately with Predator, we have a lot of data to analyze to understand the state of the nation, so to speak. We know from looking at all of the metadata across petabytes and petabytes of data that on the average 9% of backups will fail to restore and 71% fail to restore in a particular SLA, service level agreement timeframe. So what can we do about it? Well, let's look at architectural decisions. Again, we're not going into Predator at this time. Let's talk about what we can do as design architects to build your data resilience. And this is where we talk about the 4 elements or 4 fundamentals to ensure your recoverability. These are design principles, design elements. Let's go through them in turn. Air gaps, critical. Everyone talks about air gaps. Sometimes they are physical air gaps, such as physical tape media removed from the internet, or logical air gaps, such as moving from one disk system to a different type of disk system, say from block storage to object storage. We all talk about the need to have encryption, encryption at rest, encryption of data in transit. And then of course, 2 copies aren't enough anymore. We all talk about the 3-2-1 principle. Harley will have talked about it in his session. Steve Kennison, I'm sure, will talk about it in his session. 3-2-1, 3 copies of data, 2 different medium transports, 1 copy off site. Not only do we want 3 copies, but we want to ensure that 4th element, which is it immutable? Do we have, for example, write once, read many, worm type storage? And that worm, is it on tape? Is it on flash? Is it on block storage? Now they're all great fundamentals to good architecture, good data resilience architecture. But let's ask the question, do they help with recoverability? Yes. But do they ensure it? No. And the 4 fundamental elements still do not fully answer that key question, how can I recover a clean backup? At Predator, we believe that in order to completely and fully answer that question, can I recover a clean backup of my data? Not only do you need the 4 elements that we've talked about there to architecture, we need a 5th element, automation and orchestration. So let's explain that. Let's look at one of the biggest challenges facing businesses today, a ransomware attack. That moment when your hair is on fire and you're having to respond and recover. Remember that NIST framework. Respond and recover as simply and as quickly as possible. Rick shortly is going to go through a demonstration of these 4 steps that we orchestrate and automate. But let me just go through it in turn in detail. First of all, the first fundamental that we do is to automate your recovery testing. Now, we are using the processes within Spectrum Protect or Spectrum Protect Plus to do a restore of a system. It could be a virtual machine. However, if you've got hundreds or thousands of virtual machines, how do you know which ones to test? How do you know which ones may be subject to failure? Well, this is where the analytics of Predator comes in, the data lake, so to speak. By having all of that analytical data, we can start to spot particular nodes that may be subject or likely to fail a restore. We can then program or schedule those restores to take place. And then if they fail, to raise the appropriate alerts and the response accordingly. In addition to scheduled restore testing, we can randomize it as well. So again, we cycle through on a regular basis the restore testing of critical systems, which is far more measured, far more process driven than that once a year DR test that so many of us have relied upon for so long. Moving away from that fundamental practice of restore testing, which is critical, we then perform some anomaly detection. Again, using the benefit of the data lake and the analytical data that we have stored in the Predator cloud. We can start to spot when things aren't going quite as we think they should and raise the appropriate flags within Predator for you to investigate. The question is, how do you investigate? Well, we believe the way to investigate is to make an action, perform a task. So that comes on to the third phase. Let's look within the Predator system for signs of infection. Let's do a global file infection search. Let's find out which copies of our data have been infected with a particular infection signature. We can then, having found some potential threats, kick off the action by restoring into, first of all, a clean or quarantine environment. That's when the orchestration will allow us to perform antivirus scanning against those particular backup copies. Should we find dormant ransomware within that environment, the next phase of orchestration can kick in, that fourth phase, which is the cleaning of the environment, again using the antivirus. Only when we're confident that that backup is clean do we then recover into production. So this repeatable process-driven action, which is orchestrated using Predator, will hopefully give you much more confidence about how you can answer that very central question: how can I recover a clean backup? So that's the fifth element that we believe is important. I'm now going to hand over to Rick, who's going to go into the detail with a demonstration of the Predator cyber automation and orchestration technology.
Thanks for that, Al. So welcome to Predator. I'm currently logged into the Predator platform as administrator. So this is the dashboard within Predator, highly configurable as you would expect, and it gives administrators all the information they need at their fingertips. Some of our guys call this a cup of coffee experience. You log in the morning and everything you might be interested in is presented to you within one screen. So as Al mentioned, we're going to look at the automation and orchestration elements of the platform, in particular around cyber resilience. So most of our time today will be spent looking at the right-hand side at Predator IQ. So think of Predator IQ almost like a smart screen notification. This is where we pull through all the things that may be of interest to a backup administrator, whether that's backup failures, insights around storage, and in the case of today, insights around cyber resilience. And we're going to go through the four concepts that Al talked about. So we'll start with disaster recovery automation. So what we have here is the ability to automatically test your backups for recoverability. They can be done on a schedule basis, i.e. you build your own schedules and you say which workload you want testing when. It can be set to random mode, where the application will just randomly test your backups on an ongoing basis for you. Now, whichever mode you decide to run in, there is machine learning that's built into the application. So as certain backups fail to recover and certain backups do pass the recovery testing, so the application will start to build up a picture of where it believes you're most at risk from failed restore. And as we can see here in the notification panel, we have 5 potential restore failures. So if we click into this, this will open up our disaster recovery orchestration screen. And as we can see here, we've got 5 virtual machines in this instance that have been flagged as potential recovery failures. Now we can see here at the bottom, I could turn on auto testing, and the system would simply then test these at the next available time, slot them into schedules and automatically test those completely hands off. For today's test though, we're obviously going to do this manually so we can show you what happens. So we'll take the top one in the list, we will add that into our test queue, and we will begin test selected backups. So what the application will do here now is upload this to the target of your choice, in this case the IBM cloud, and it will begin a controlled recovery and restore of that, and obviously test to see whether that workload will recover. Now, just while that's running in the background, let's have a little look at this report here. This report can be run at any time, and it will basically show you on a single screen the risk or the exposure of failed recovery that you have within your application. So we can see what's past restore, what's still at risk of failed restore from a prediction point of view, and really importantly, what have we tested where we've had failures and an administrator is yet to put the corrective action in place and rerun those tests. So very, very quickly, at any point, if you want to understand where your risk sits with a data outage or any other kind of data loss, this screen is designed to give you that confidence and that visibility of what the recoverability of your estate looks like. So let's just close this report down and hopefully our test is completed. So as we can see here with this one, we have run a restore test and it's actually successfully restored, which is great. So in this case, we predicted there was a risk of failed restore, but actually we've proved that to be false. And actually we've got the right result, which is a successful recovery. So it's with this tool here that we answer point one, which is how can I be sure my backups will recover? And the answer from a Predator point of view is ongoing automated DR testing to give you that confidence and that visibility. So now let's look at point two of the question, which is if I'm confident my backups will recover, how can I be confident they don't contain dormant ransomware and I simply reinfect my estate with the ransomware I'm trying to remove in the first place? So three parts to that, and that starts, well, part one starts with our anomaly detection. So we can see here in the smart notification panel that we've got some suspect backup behavior. And if we click on this, we can see a number of things here. So we have a number of backups that have been flagged as suspect. And if I hover over these, it will show me why it's been flagged as suspect. So this one here contains in the metadata a reference to goldeneye.exe, which is a common piece of ransomware that was doing the rounds 6 months ago. This is a new feature that's coming out next year. We will have the ability on a nightly basis to basically search across your backup estate at metadata level, looking for any instances of known ransomware, and then simply flag those backups where we can see references within the metadata. Again, that feature is coming Q1 into Q2 of next year. If I hover over the one below, we can see here this one has been flagged because the gigabytes transferred has suddenly increased significantly compared to the previous 90 days of behavior. Now with this here, we do have some machine learning that's built in here, again, some smart analytics. And let's say, for example, you do incremental backups and then you do a full backup once a month. Over time, the Predator platform would start to understand and learn that behavior for this certain backup and stop flagging that as an anomaly. So what we're going to do for speed is, again, we'll take the top one in the list. We'll put that in our quarantine area, and then we're going to kick off a scan. So what this will do here is upload that to our clean room or a recovery target. Again, our clean room for today is in the cloud. It will recover that backup. To give that a second, and then it will run a virus scan against that recovered workload. And in a moment or two, it will present the results of that scan back to us through the front end of the application. So as we can see here, we found, or this backup was flagged because we could see references to goldeneye.exe within the metadata. We have now run a deep antivirus scan against that recovered workload, and we can actually see confirmed we do have ransomware within that backup. So if I click on that now, I can do two things with one click here. So when I click this, first thing it's going to do is instruct the antivirus within our clean room to go and attempt to clean goldeneye.exe out of that backup. And while that's happening, the application will then search across all of your backup estate, both Spectrum Protect and Protect Plus, at metadata level for any other instances where we can reference GoldenEye. And we can see here there are 4 nodes that have been found that reference GoldenEye. The red blocks show you where we can see a reference. The green blocks mean we can't see a reference to GoldenEye. So potentially the green blocks are clean of ransomware. The red blocks are potentially infected. So you have 2 choices here within the infection map. As a standard, if I click on these, which I'm going to do now, this will, the Predator will recover the latest infected copies, so the ones from earlier today that were backed up. but I could click on the relevant green blocks and bring back the latest suspected clean copy and do an antivirus scan on those. So as an end user, you have a decision here really. Do you want to recover the latest infected copy and attempt to clean that securely within the clean room? Or do you want to play it really safe and bring back the latest potentially clean copy, knowing that you may lose some data, and then validate that that is actually clean before you actually decide what you want to recover back to your live environment? So we'll just leave it to take the latest infected copy. Let's click on that and we can see that goes straight into our quarantine queue, and then we can kick off an upload and a deep scan of those. Now we won't wait for that to complete because that will take some time. What I will show you though is, now that we know we have a confirmed case of ransomware within our backup estate, Predator will raise a ransomware case within the Predator application, and then we have APIs that work with the Splunk, QRadar, ServiceNow, those type of applications that you may use as your SIEM solution. We can pass those tickets out to those applications, then you can obviously kick off the relevant workflow within your organization to inform the relevant people, and obviously maybe get the right working parties together and try to understand the spread and impact of ransomware within your business. So just to recap there, we've seen 4 things. We've seen our automated disaster recovery testing. We've seen the anomaly detection, which is working off both gigabytes transferred, and then coming later this year, the ability to search metadata on a nightly basis for known infection signatures, followed by the ability to push suspect workloads into a clean room, to do a deep AV scan on those, and also a clean, giving you the option then to be able to push those back to a live environment once you're confident they have been cleaned. So we'll stop the demo there, and Al, I'm going to pass back to you.
Thank you, Rick. So we've talked about the threat. We've talked about the importance of good architecture, good principles of design, with the 4 key elements: air gaps, encryption, numerous copies, and immutability. Hopefully now you see the 5th element and the importance of that 5th element, which is Predator, orchestration, and orchestration technology laid on top of that Spectrum Protect architecture. Now can you answer that question? Can I recover a clean backup? Well, we certainly feel more confident knowing that's in place. So just to summarize the 4 key things that Predator does, certainly in terms of cyber resilience: automated recovery testing, backup anomaly detection, automated antivirus scanning, and finally automated backup cleansing using AV. They're the 4 things that we do to help you guarantee and ensure the recoverability of your most critical data. If you've seen enough or whetted your appetite to find out more about Predator, please do reach out in the Q&A chat to book your own personalized session to dive into Predator to see if this technology would be a good fit for your needs and your environment.